Okay, so today we are going to discuss about how to solve the system of linear equations. So in physics we often encounter a system of linear equations. For example, while solving the circuits by applying KVL or KCL, Kirchhoff's voltage law or Kirchhoff's current law, we encounter such linear equations, and in mathematics also we learn how to solve them. In mathematics we often have the equations in the form like this. Suppose these are a system of linear equations. It is like, for example, 2x plus 3y plus 4z equals to some quantity, suppose 5. Then x plus y plus z equals to 1. Arbitrary equations I am writing here. And then suppose some x to y, then 2z equals to 7. So these are you can call it a system of linear equations, right? And you can also write them in the matrix form, right? You may know about them, that the general form of a linear equation can be written in a matrix form, where what are these quantities? This A matrix. What is this A matrix? This A matrix is the coefficient matrix, right? So when I write this 3x plus 2y plus z, so these are the coefficients of the variables x, y and z, right? So the coefficients are here, the coefficients are 3, 2, 1, 1, and all these coefficients can be gathered together in a matrix, and this is called as the coefficient matrix. And what is this x? X is a column matrix, and this holds all the variables. In our example, it was x, y and z. Suppose there are n number of variables, and we are naming them as x1, x2, x3 up to xn. And in the right hand side also there may be some values, and they are together in another column matrix, and that matrix is usually represented by this another matrix in the right hand side, B. And do you know how to solve this equation? How to find the variables x, y and z? Do you have? Yeah. So there was something known as Cramer's rule, Cramer's method. Do you remember? In 11th or 12th? Yeah. So we can also do to solve this equation, to find what is x, y and z. And this type of equations are known as non-homogeneous type linear equations, right? Non-homogeneous type system of linear equations. And what is homogeneous type? Homogeneous type means Ax equals to 0, right? The right hand side must be, all of them should be 0, right? Do you remember, or do you know about? Yeah. So these are the other kind is known as the homogeneous form of the system of linear equations, and this is the non-homogeneous type. The solution of homogeneous type is you can do them, and the trivial solution is that all of them are 0, right? All the variables are 0. This is the trivial solution. And what is the condition for a non-trivial solution? The condition for non-trivial solution is that the determinant of A must be equal to 0 for this homogeneous type. And there are other methods to solve them, and they are not much important here. So usually we encounter this non-homogeneous type system of equations, and for homogeneous type you can solve them by using some other methods. Okay, so here we are going to discuss about the non-homogeneous type only. So here is an example. If n equals to 2, that means this n cross n matrix or n cross n coefficient matrix, if the value of n is 2, then it will be, the coefficient will be a 2 cross 2 matrix, and this is the form of the equation. and for n equal to 3 there will be 3 cross 3 coefficient matrix, and there will be 3 variables and 3 quantities here on the right hand side, right? So this is the form of system of linear equations, and we can how to write them in the matrix form. Now what are the methods to solve them? So there are several methods. The first one we usually learn is the Cramer's method in the school. Then the Gauss elimination method, we are going to learn about it in detail. And there is another one called the Gauss-Jordan method. We are going to skip this part, and that is not much important. And if you want to learn, you can learn it from the book. So we are going to mainly focus on this Gauss elimination method. Have you learned about it before? Okay, so in 12th I did not read this part. So for the first time I read this in BSc, I think. Okay, so in the 12th I know about only the Cramer's rule. Okay, so in this course we are going to learn how to solve this method numerically first, and before that let's go through them a bit quickly, like how to solve them analytically by hand. So let's yeah, it is also true. That can also be done. Yes. So by how to do that? You have to find the inverse of the matrix, right? And then just multiply it, and then that can be also true. Yeah. So that is also another method, and here we are going to learn about the Gauss elimination method and how to implement them in Python, right? Okay, so before that let's just give you a quick review of the Cramer's rule. So you know, so maybe other people don't know in the class, in the classroom. They are also there, but they are not able to attending the live classes. So they are just there to see the recorded classes. Okay, so let's discuss the Cramer's rule. You may have learned about it in 12th, and this method is suitable for solving a system of few equations, maybe n equals to 2 or 3. That is suitable, and if n equal to 4 or 5, then that will be a bit difficult to solve. You can do it, but that will take too much time. And the solution of this system of equations Ax equal to b has the form xi is equals to determinant of ai and the determinant of A matrix. So what is the determinant ai? The determinant of A, you know, the determinant of the coefficient matrix, right? The determinant of this coefficient matrix. And what do we mean by determinant of ai? Determinant of ai is the determinant of same matrix A, the same coefficient matrix A, but its column matrix I is replaced by the vector B. So let's see an example to understand it, how to replace the column I by the vector B. So, let's use the Cramer's rule to solve this system of equations. So what are the equations? Explicitly I can write them as 3x1 minus x2 equal to 4, and 2x1 plus 4x2 equal to 0, right? So these are the equations, and I am writing these two equations in this matrix form, right? So these are the coefficients of the variables, and these are the variables x1 and x2, and these are the non-homogeneous part 4 and 0. This is the matrix, and this is the column matrix, and this is the non-homogeneous part column matrix. And what is the determinant of this matrix? The determinant of matrix can be found as this, right? 3 into 4 minus 2 into minus 1, right? So that will be 12 plus 2, that is why it is 14. So that the determinant of this matrix. And then how to find x1? To find x1, you have to replace the first column with this vector b, with this column vector b, right? Because I have written that xi is determinant of ai divided by determinant of a. And what is this ai, determinant of ai? It is the determinant of the matrix where you replace the ith column with the vector b. So for this x1, you have to replace the first column with this vector b or column vector b, column matrix b. And if you replace them and then take the determinant, this will be 16 by 14 and the x1 value will be 8 by 7. Then for x2, you have to replace the second column, right? And here you have to replace the second column with this b matrix, b column matrix again, and the answer will be minus 4 by 7. So this is the value of x1 and x2. Using Cramer's rule, you got the values of the variables x1 and x2. If there were 3 columns, then you have to find x3, right? If there was another variable x3, then while solving them, you have to put the b vector in the third column. There will be the coefficient matrix will be like this, and here you have to put the b vector, right, in the third column. So depending upon which variable you are solving, you have to replace that column with the b vector here, right? So that is how you solve it. Okay, so that is Cramer's method. Now let's come to the Gauss elimination method. So this method is divided into 2 main steps as follows. Let's jump into it. The first step is forward elimination. If the system of equations consists of 3 equations like this, there are 3 variables, and so there will be 3 equations, and this will be the coefficient matrix, and this is the variable matrix, and this is the non-homogeneous part. Then what is the first step in this Gauss elimination method? The first step is known as the forward elimination. In this first step, what we are going to do, we are going to modify this column matrix, the coefficient matrix, so that the coefficients beneath the diagonal line are 0. So in this method, what we are going to do in the first step, is the forward elimination. In the first step, what we are going to do, we are going to try to make the coefficients or the elements of the coefficient matrix below the diagonal line to be 0, right? So this is the diagonal line. This is the diagonal line, and we have to make all the elements below the diagonal line of the coefficient matrix to be 0. And if you do that, that will be helpful for you, because now if you see what will be the equations, the equations are going to be easy to solve, and that can be done in the next step, right? That next step is back substitution. So if you do that, that means if you make all the elements below the diagonal line to be 0, then what will be the last equation? The third equation. The third equation will be just a33 x3 equal to b3. And why there are these dashes here, this single dash and double dash? Because the elements will change. Here, as you can see, that the elements were a22, a23 and a33 like that. But when we carry out this method of the forward elimination, the elements are going to change. So that is why we are denoting them by a22 dash and a23 dash and a33 double dash. These elements will remain same. These a22 will change once, and a23 will also change once, and a33 will change twice. That is why there is a double dash symbol. And similarly also this b1 will remain same, b2 dash will change, and b3 also change, and it will change twice. So when we carry out this forward elimination, the elements will change in the coefficient matrix and also in the non-homogeneous part, right? And after doing this, you see that it will be very easy to solve for the variables x1, x2 and x3. The first one we are going to find is the value of x3, because the last equation will be just like this, right? a33 double dash x3 equals to b3 double dash. So from that you get the value of x3, right? And then from the second equation, what will be the second equation? The second equation will be a22 double dash x2 plus a23 dash x3 equals to b2 dash. And from that you can find what is the value of x2. You know all the quantities, you know what is the value of x3 from here, and you know the other quantities, and from that you can find x2. Now you know x3 and x2 value, and after that, what is the first equation? The first equation, you have to multiply them, and the first equation will be like this. And now you know what is the value of x2 and x3 and all other values, so that will be the value of x1. So what is the first step? The first step is forward elimination. In the forward elimination step, you have to make all the elements below the diagonal line of the coefficient matrix to be 0, and in the back substitution or in the second step, you have to solve for the equations here. You have to solve all these equations. From below you have to solve. First solve for x3, then you will solve for x2, and then finally you have to solve for x1, right? So that is how you do. Is it okay, or is there any problem? Okay then. So let's see an example. Let's see this method in action. So let's use this Gauss elimination method to solve this system of linear equations. You can also solve this first by Cramer's rule and get the values of x1, x2, x3, and then we are going to solve it using the Gauss elimination method, and you can try to match the values. It is giving the same result or not. So this is the system of linear equations given to you, and now you can write them explicitly as, right? In this way you can write them here. So here this is 4 into x1 minus 4 into x2 and 0 into x3 is equal to 4. Then minus x1 plus 4x2 minus 2x3 equal to 4. The right hand side, all the elements are 4, and the last equation is what? Minus 2x2 plus 4x3 equals to 4, right? So in the first step, forward elimination, what we are trying to do, first what we are trying to do, that we want to eliminate all these elements. We want to make them 0, right? So this element is already 0. We need to do what we need to do now to make this is 0 and this element as 0. Then all the elements below the diagonal line will be 0, right? So that is the first step in the forward elimination method in the forward elimination step. Okay, so step 1, forward elimination. So this is the first loop. So so I am writing them as loop because in programming also we are going to solve them loop wise. In the first loop, what we are trying to do, in the first loop we will make all these x1 values disappear, right? So if there are some x1 value, like suppose 2, not 0, then in the first loop we will make vanish all these x1 values, right? The coefficients of x1, right? So this minus 1, the coefficient of here, the coefficient of the coefficient of x1 is here -1, and suppose the coefficient of x1 is 2, suppose let's take as 2. Then in the first loop, what we will do, we will try to make all these coefficients of x1 as 0. Then in the second loop, what we will do, we'll try to do all these coefficients of x2 as 0, right, and so on. So first loop. So this method starts from dividing equation 14 by coefficient of x1. So this is coefficient, this is the equation 14, and let's divide this equation 14 by the coefficient of x1. What is the coefficient of x1 here? It is 4. So divide this equation by 4 and you will get this equation. Then multiply it with the coefficient of x1 from equation 15. Then multiply equation 14 with the coefficient of x1 from equation 15. That means multiply -1 throughout this equation. So that will, so if you multiply -1 here throughout this equation, you will get this equation, right? -x1 plus x2 equals to -1. Now what you need to do? Subtract equation 18 from 15. Subtract this equation 18 from 15, from equation 15. Now if you subtract it, this x1 will vanish, right? And this x1 will vanish, and this equation 15 will become this 3x2 minus 2x3 equals to 5, right? So our goal is achieved. In this first loop, we wanted to eliminate this x1, right? This x1 quantity here from the equation 15. So how we are doing it? We are choosing this equation 14. Let me give you a summary. We are choosing this first. We are choosing this equation 14. We are dividing the coefficient of x1 here throughout this equation, right? Then we are multiplying the coefficient of this equation, the target equation. This is the target equation. The coefficient of this equation here. Then we are subtracting them. We are subtracting the modified equation, the modified first equation from this equation. And what is the purpose of doing all these things? To make this -x1 vanish, to eliminate this -x1, right? And similarly you have to repeat this process to eliminate the x1 quantity here, but luckily there is no x1 quantity in this equation 16, right? So if there was a x1 quantity here, suppose there was something like 5x1, then you have to repeat all this process again. To first you have to divide this equation by 4 and then multiply this equation with 5, and finally subtract this modified equation from this equation 16, and then you will eliminate this x1 quantity from this equation 16, right? In the first loop of the forward elimination, you have to eliminate all the x1 quantities, x1 variables from these equations, right? And here in our example there is no x1 here in this equation 16, so this equation 16 will remain same, just the equation 15 will change, and equation 14 is as it is there, that will not change. So after this first loop of forward elimination, what you will get, the equation, the first equation will remain as it is, this equation will change and this equation will also change, but here the x1 value was already 0, that is why this equation is as it is, right? This equation is as it is, but it should have changed if there was a x1 quantity here. So in the first loop of the forward elimination, you have to eliminate all the x1 quantities below this first equation. Then in the second loop, you have to eliminate all the x2 quantities, all the x2 below this second equation, right? To make them diagonal, to make the coefficient matrix diagonal, right? Is it okay, or was there any problem? Okay, then similarly in the second loop, what we are trying to do, we will try to eliminate this x2 here in this third equation, right? So in this next loop of forward elimination starts with equation 22, then divide this equation 22 with 3 everywhere, the coefficient of x2, divide the coefficient of x2 throughout these equations, throughout these quantities here, and this will be the equation. Then multiply it with the coefficient of x2 from equation 23. What is the coefficient of x2 from equation 23? It is a -2. So multiply -2 everywhere in this equation. And now what you have to do? You have to subtract this equation from this equation 23, right? So subtract this modified equation of equation 22, that is in equation 25, subtract it from equation 23. And what is the purpose of it? The purpose of it is to eliminate this x2 value here, right? So here we are doing that, we are subtracting it, and finally we are done with it, and the value of equation is like this: 8 by 3 x3 is equals to 22 by 3, right? Give me 1 second please, a lot of noise coming. Right, so that is how you have to do it. So this is the second loop, and you have eliminated the x2 value from here, and now your coefficient matrix is diagonal. So after the second loop of forward elimination, the system of equations will be like this. You have eliminated all the elements below the diagonal, and this will be the form of equations, right? And the values here also, they will also change. And what is the second step? The step 2 is back substitution. First you have to solve for this x3. This x3 will be 22 by 3 divided by 8 by 3, right? So from this last equation you will get the value of x3. Then from the second equation you will get the value of x2, and then from this x3 and x2 values you have to find what is the value of x1, right? By starting from the last equation, the solution of x3 can be obtained. The computed solution of x2 is used to determine the computed value. The solution of x3 is used to determine the values of x2 and then x1 respectively. So by back substitution, you have to solve. You have to find what is the values of x3, x2, and x1, right? So that is the method. Is it okay, or is there any problem? Okay, so that is the Gauss elimination method. This was an easy example, and we saw how to apply the forward elimination and the back substitution. And in the next class we are going to learn the general method. The general, like suppose there are n number of linear equations, and how to implement this Gauss elimination method there analytically, and then how to solve them numerically using Python, right? So what is the limitation of this method? Can you tell me why? So when will be this method is not very suitable? When it will be not suitable to solve? Do you know? Yes, when these diagonal elements are 0, then this method will not be suitable to solve the equations, right? Or the x1, x2, and x3 values. Why? So why this diagonal value? If this diagonal value is 0, then it is not suitable. Can you tell me? Do you remember why? Right, okay, so here what if this diagonal values are 0 in this example? Then what will be problematic? Because when you start this method, you have to divide the suppose this is, it is 0 here, 0 here, 0 here. Then to eliminate this -1 in the first step, you have to divide the coefficient of x1 here throughout this equation, and then you have to carry out the further process. But here, as you can see, that the coefficient of x1 is actually 0. That is why you cannot divide it anywhere. And also this method is only suitable when only the elements below the diagonal are 0, right? And if these elements are also 0, then you cannot divide them, right? So here what I was doing here, as you can see, that in the first step the method starts from dividing this equation 14 by the coefficient of x1. What was the coefficient of x1? It was 4. Now all the diagonal elements, if 0, then this will be 0. and you cannot divide 0 throughout this equation, right? That is why if these elements are 0, then this method is not suitable, right? Is it okay? Okay then. Okay, so we are going a bit slow. So okay, so that is it for today, and let's meet tomorrow in the morning. Is it okay? So we can meet at 8 a.m. right, tomorrow. Okay then. So let's meet tomorrow in the 8 a.m. and we will discuss further. So this is the Gauss elimination method for a system of n linear equations. Then how to generalize this process and how to implement this process in Python. Okay. Okay, so that's it for today. Okay, so are you currently in MSc or is it over? Oh, okay. Now then, so is there any thesis work? Okay, so what is your research area? What is your dissertation area? Oh, okay then. Okay then, so yeah, that is nice. Okay, so let's meet tomorrow and we'll continue. Uh-huh. State college? What you ask? State Odisha. Oh, okay. अच्छा ओडिशा रे ना अच्छा साहू टाइटल हाँ ଜାଣିପାରିଲି କୋଉ ଜିଲ୍ଲାରୁ